Ever wondered how particles scatter off of a solid object in quantum mechanics? In today's video, we'll break down the phase shifts for hard sphere scattering, and in doing so, we'll break down a lot of math that is needed in other parts. In particular, what we see here is the cross-sectional scattering for several different situations with k times a, and I will link this image and its resource below. But as you see, it is quite important to us in quantum mechanics for several reasons, which we'll discuss soon. But in order to tackle this problem, we actually have to go through quite a few things. And we'll start with example 10.3, which is the quantum hard sphere scattering, and then we'll get to problem 10.6, which is what are the partial wave phase shifts, delta L, for hard sphere scattering that was done in example 10.3. And in the process of doing this, we'll also cover problem 10.3. So you're actually getting a 3-for-1 here, and it's actually going to be a lot of fun. But why do we care? Well, in the quantum hard sphere, it provides a simplified
I'm not
yet
saying they really
insightful
like
model
me,
to
but they don't have
understand
a
how
reason to
quantum
hate
particles
me. It's like I'm
interact
a
with
quiet
obstacles.
neighbor. I don't
And
do
when we see
anything.
what the
It's
potential
fucking
is, it'll make sense why it's considered, quote, hard sphere.
right next to the golf course.
Again, not going to be that much similar to what we see in the classical side of things,
wasn't
but
that way when we
the challenge is, how does this compare with the classical analog? And we'll have to definitely feel it out and see what's going on there, because there is an analogy there, but it's not what you might think. At least not what I thought at first. And if you want the PDF,
I like to guess
please comment. I'll
one
be
of them
happy to share it with you, or you
that
can go to
was
the Patreon,
colluded, maybe.
collection,
One of
grab
them
all the
that
YouTube,
wasn't colluded but
PDFs,
ate it because
all
they
free
weren't
for members,
colluded
so
and just
get out there and go
regular
get
hit by
'em.
a car or something.
And
Usually
if you're
how I
curious
play it.
about the world of science, please be sure to subscribe. I post educational content every week to quench your thirst for curiosity. So with this, let's jump into this video. With that. Alright, anyways. So, step number 1, of course, we have to first cover the quantum hard sphere scattering case from example 10.3 from the perspective of partial wave analysis via the partial amplitudes that we had seen in a couple other problems. Okay, and then from that, we can use those to construct and find the phase shift constructions. So the potential here is that V of x is equal to infinity for any r less than the radius of the sphere, so that'd be little a. Okay, so infinity, we know it has to happen with infinities in quantum mechanics. Okay, so this is considered hard sphere, and then we're 0 outside. So we have a hard disruptive figure that we have to deal with. Okay, and it gets spheres and spherical harmonics, all things like that, they work together really well. But what we realize here is that with this potential, the boundary condition needed is that the wave function at the boundary of the sphere has to be 0 because of infinity. Okay, so that makes sense. Now if we couple this with the general solution of the wave function for these problems and these scattering problems, which is given by the summation, it all needs to equal 0. And in fact, this holds for all theta. The partial wave amplitudes here is what we need to find, and that's what's of importance to us. And to do that, we have to use an old friends that we had dealt with back in chapter 4, which is multiplying by a Legendre polynomial with the L prime, and then integrating over theta, which is 0 to pi on both sides. And why we do this is because we want to exploit the orthogonality of Legendre polynomials. And again, we did that back in chapter 4. I'll go ahead and link that as well, or you can grab it from the PDF. But this, in essence, finding this AL is what problem 10.3 is trying to do. So we'll go ahead and find that result in the middle of this example.
Here, a 4x4, whatever, but I just think this works good to
Faraday
quantum
suit.
physics. You get your one stage, your binary models, chessboard entropy design, which is, again, anything that we
To
want
scale.
to scale from chessboard design.
Maybe
to
map a town.
pieces
Maybe map your house.
configuration to
The Book of the
anything
Mother's
that you
bathroom
might
wave
parallel
function. That's
into
actually
a moving something around. This is a landscaping
This, the IMA program. This.
All right, you ready? What we got here?
Indentured
Here we got
servitude
bones
for the
book.
first 90 days.
Found, please return to any salty. This is generally where it starts for me.